हेलो स्टूडेंट्स एंड वेलकम टू दिस स्पेशल मास्टर क्लास। आज हम कुछ बहुत इंपॉर्टेंट फिजिक्स एमसीक्यू सॉल्व करने वाले हैं, chosen from a list of 100 must-do questions. This is really gonna supercharge your final preparation.
Okay, so we've broken down these questions into four main topics. पहला है fields and forces, फिर current and circuits, उसके बाद magnetism and AC, और finally modern physics. Think of it like a roadmap for our revision. चलो, let's get started.
Alright बच्चों, let's begin with our first section. ये electrostatics and capacitors के foundational concepts हैं. So make sure you're paying close attention. Let's build a strong base.
चलो पहला सवाल देखते हैं। हमें ग्राफ दिया गया है कूलम फोर्स F वर्सेस 1/r² का। इस ग्राफ को देखकर हमें चार्जेस Q1, Q2 और Q3 के मैग्नीट्यूड को कंपेयर करना है। सो द करेक्ट ऑप्शन हियर इज A। इस क्वेश्चन का आइडिया बहुत सिंपल है। कूलम्स लॉ क्या है? F इक्वल्स K Q1 Q2/r²। तो F वर्सेस 1/r² ग्राफ का स्लोप प्रोडक्ट ऑफ चार्जेस के प्रोपोर्शनल होगा। यहाँ Q1 Q2 वाली लाइन का स्लोप ज़्यादा है, इसका मतलब Q1 Q2 इज ग्रेटर देन Q2 Q3। अब क्योंकि Q2 कॉमन है, इसका सीधा मतलब है कि Q1 मस्ट बी ग्रेटर देन Q3। और क्वेश्चन में दिया है Q2 सबसे छोटा है, तो ऑर्डर बन गया Q2 लेस देन Q3 लेस देन Q1। सिंपल।
ओके, नेक्स्ट क्वेश्चन। ये क्लासिक कॉन्सेप्ट बेस्ड सवाल है। एक चार्ज्ड हॉलो मेटालिक स्फीयर है, उसके अंदर इलेक्ट्रिक फील्ड यानी E और पोटेंशियल V की वैल्यू क्या होगी?
एंड द करेक्ट ऑप्शन इज B। बच्चों, ये एक डायरेक्ट कॉन्सेप्ट है। एक हॉलो कंडक्टर के अंदर इलेक्ट्रिक फील्ड E हमेशा जीरो होता है अकॉर्डिंग टू गॉसेस लॉ। अब क्योंकि E इज इक्वल टू माइनस dV/dr, अगर E जीरो है इसका मतलब V को कांस्टेंट होना पड़ेगा, और ये कांस्टेंट पोटेंशियल सरफेस के पोटेंशियल के बराबर होता है।
चलो अब इस सर्किट को देखो। हमें दिया है कि 20 माइक्रोफैरेड कैपेसिटर के लेफ्ट प्लेट पर -50 माइक्रोकूलम चार्ज है, और हमें 12 माइक्रोफैरेड कैपेसिटर के राइट प्लेट पर चार्ज निकालना है।
इसका करेक्ट आंसर है D। चलो इसे स्टेप बाय स्टेप सॉल्व करते हैं। सबसे पहले 12 और 8 माइक्रोफैराड वाले कैपेसिटर्स पैरेलल में हैं, तो उनका इक्विवेलेंट हो गया 12 + 8 यानी 20 माइक्रोफैराड। अब ये पूरा सर्किट सीरीज में है और सीरीज में चार्ज सेम रहता है। इसका मतलब उस पैरेलल कॉम्बिनेशन पर भी टोटल चार्ज 50 माइक्रोकूलम है। अब ये चार्ज पैरेलल में डिवाइड होगा कैपेसिटेंस के रेशियो में, तो 12 माइक्रोफैराड वाले पर चार्ज आएगा 12 डिवाइडेड बाय 12 + 8 इंटू 50, जो सॉल्व करके 30 माइक्रोकूलम आता है। पोलैरिटी की वजह से राइट प्लेट पर चार्ज होगा -30 माइक्रोकूलम।
Okay, let's keep the momentum going. We'll tackle a few more questions on electrostatics, applying these same key concepts.
Alright, time for our second section. अब हम current, resistance and all their related effects पे फोकस करने वाले हैं। This is a super important topic. Look at this question. We have two wires, P and Q, made of the same material. The catch is, wire Q has double the diameter and half the length of wire P. हमें wire Q का resistance बताना है P के terms में।
And for this, you absolutely need to remember this formula. R is equal to rho L by A. Resistance depends on resistivity, length, and cross-sectional area. This is a fundamental one.
The correct option is C, R/8. यहाँ बस फॉर्मूला में वैल्यूज डालनी है, लेकिन एक चीज का ध्यान रखना, और ये कॉमन मिस्टेक है। जब डायमीटर डबल होता है तो एरिया 4 टाइम्स हो जाता है, क्योंकि एरिया इज प्रोपोर्शनल टू द स्क्वायर ऑफ द रेडियस। सो लेंथ हुई हाफ और एरिया हुआ 4 टाइम्स, तो टोटल फैक्टर 1/8 का बन गया। सिंपल कैलकुलेशन।
Okay, next up is a question on Joule's law of heating. The question says, if current I causes a temperature rise of 0.5 degrees Celsius, what will be the rise for a current of 2I?
The right answer is C. According to Joule's law, heat produced is proportional to I squared. So if you double the current from I to 2I, the heat produced becomes 4 times greater. That means the temperature rise will also be 4 times greater. So 4 multiplied by 0.5 gives you 2.0 degrees Celsius.
All right, on to section 3. We're now diving into magnetism and AC induction. Pay attention, Butcho, because these are very high-scoring topics in your exam.
Now look at this diagram-based question. We have a circular loop where current enters at point A and exits at point B. The question is, what is the magnetic field at the center? Oh.
The correct answer is B, 0. इसको याद कर लो, this is the standard result. The current splits into two parts. If you use the right-hand thumb rule, you'll see that the magnetic field from the upper arc is exactly equal and opposite to the field from the lower arc, so they completely cancel each other out at the center.
Here we have a very direct, formula-based question. An AC circuit's voltage and current equations are given. We just need to find the average power consumed.
And the correct option is D. This is straight from the formula book. Average power in an AC circuit is Vrms times Irms times the power factor, cos phi. And remember, Vrms is peak voltage V0 by root 2 and Irms is peak current I0 by root 2. जब आप इनको मल्टीप्लाई करोगे, you get V0 I0 by 2 times cos phi. ऐसे formula based questions एग्जाम में बहुत आते हैं.
Okay, our next question is from the topic of dimensions. हमें self-inductance की dimensions बतानी है. The correct option here is D. देखो, whenever you need to find dimensions, find a simple formula that contains that quantity. यहाँ, the easiest formula is the energy stored in an inductor. E equals half L I squared. Just rearrange this for L, put in the dimensions for energy and current, and you'll get your answer. Easy peasy.
All right, an LCR circuit question. We have a series LCR circuit. As we increase the frequency, what is the nature of the circuit before and after resonance?
The answer is C, capacitive and then inductive. Iska logic simple hai. At low frequencies, XC, which is 1 by omega C, is very high. So the capacitor dominates and the circuit is capacitive. At high frequencies, XL, which is omega L, is very high. So the inductor dominates and the circuit becomes inductive.
Chalo, we're on to our final section now. Waves, photons, and nuclei. This is modern physics, Bacho, and it's full of easy, scoring questions. Let's finish strong.
Take a look at this graph. It shows the relationship between energy and wavelength. We need to identify what the points P, Q, and R could represent.
And the correct option is B. The key here is the formula E equals hc by lambda. Energy and wavelength are inversely proportional. So jiska wavelength sabse kam, uski energy sabse zyada. Point P has the lowest wavelength, so it must have the highest energy, which corresponds to X-rays. Point Q has the highest wavelength, so lowest energy, that's microwaves. For this, you absolutely must know your electromagnetic spectrum.
Next question is about nuclear radii. We have two nuclei, A and B, with mass numbers 27 and 64, respectively. We need to find the ratio of their radii, Ra by Rb.
The answer is D, 3 by 4. This is a direct formula application. The formula says that the radius is proportional to the cube root of the mass number A. So you just need the cube root of 27, which is 3, and the cube root of 64, which is 4. So the ratio is simply 3:4.
In this question, we need to figure out which atomic transition will emit a photon with the maximum wavelength.
The correct option is A. Now remember, maximum wavelength means minimum energy because they are inversely proportional. The energy of the photon is equal to the energy gap between the levels. As we go further from the nucleus, the energy levels get closer and closer together. So out of the given options, the energy gap between n equals 4 and n equals 3 is the smallest. Minimum energy gap means maximum wavelength.
Okay, a semiconductor question. A germanium crystal is doped with boron. What will be the charge carriers in this case?
The correct option is C, holes and a few electrons. Here's why. Germanium is from group 14, it's tetravalent. Boron is from group 13, it's trivalent. When you dope a tetravalent atom with a trivalent one, you create an electron deficiency, which we call a hole. This results in a p-type semiconductor, and in a p-type semiconductor, the majority charge carriers are always holes.
And that's the approach you need to take for all 100 questions. We've covered some of the most important patterns and concepts today. The main takeaway is this: focus on understanding these core ideas and formulas, because these are the types of questions you're definitely going to see. So, what's next? The most important thing now is self-assessment. After going through these questions, ask yourself, which topic feels like you're strongest? And which one are you going to practice more tonight? Be honest with yourself and use your revision time smartly. All the very best for your exams. You're going to do great.